Hi. So, this is it. Integral of secx dx. Okay, what is it? That is a pretty hard question. Okay, to be honest, you kind of need to have seen the answer and the method to try and memorise how it works. But it's a really, really nice solution to it. Okay, really, really nice solution. Let me tell you what the answer is. Okay, natural log sec x plus tan x plus c. And you're probably thinking, did not see that one coming. Because there's nothing really to suggest in that it's going to be this, is there? Okay. If it's a show that, makes it easy. Show that this equals this. So you can then, well, not cheat, but sort of go the other way around. You can go from this to this by differentiating that. Remember, differentiation, always easy. Integration, tricky. Okay. But we will do it the integration way, don't we? Okay. So let's do it the integration way. Okay. I'm going to need quite a lot of the board space, probably. Okay. So I'm just going to write it here as integral of 1 over cos x dx. Because then you might be thinking, well, okay, then maybe that's where the natural log is coming from, because we've now got a fraction, but it's still not enough, is it? Okay. You've got to do something with it, okay? And it's the sort of thing you don't really think of doing until you've done this quite a few times, or unless you've seen the method, okay? Right, the method is you're going to multiply the top and bottom of that fraction by cos x. Okay? So if I multiply the top by cos x, I'm going to get this. Multiply the bottom by cos x, you get that, cos squared x. Is that okay? So let me just write that a bit neater, because you're going to take a screenshot of that, aren't you, probably, when I get to the end of the board. Yeah, so that's the same. You agree with that so far? Yeah, good. I'm glad you agree. Yeah. Right, well, what can we do with that? Okay. So we're going to write it as cos x over and cos squared x. One of the things that you should think about is the identity for that, which is this. 1 minus sine squared x. And you're thinking, I'm still not sure where this is going. Okay. Stand by. We're going to do a substitution. Yes, we are. Substitution. Don't we love substitution? It's great. Okay. And the substitution we're going to make is, you think of it? Okay. Yeah. Right. U is equal to sine x. I'm sorry, you're thinking of something else. Okay. Well, when I say substitution, you've got a choice, haven't you? Either u cos cos x or u cos sine x. Okay. If you've done enough substitution questions by now, you know that sine x is the one to go for. Why is that? Well, you'll see. Okay. So what we're going to do is we're going to work out du dx, and that is equal to cos x. And then we're going to work out what dx is, and that's going to be du over cos x. You see it now? Yeah, good. The cos x is going to cancel, isn't it? Because when you put this into this, you get du over cos x. Let me do that now. Okay. No, I'll tell you what, I'll keep going and I'll just, I'll manage it somehow, okay? So we'll have cos x over 1 minus sine squared x. Nope, that's not what I wanted to write. Sine squared x multiplied by, what do I want to write now? Du over cos x. Sorry, it's been a bit messy. Okay, there we go. Right. And the next line I'm going to write out is this. Okay, there's no way I'll get to it at the end of one board, by the way. Okay, so what it's 1 over 1 minus sine squared x, which is u, isn't it? 1 minus u squared du. Okay, happy with that? Yeah, good. So you might think, is that much easier? Yes, it is. What you do now? Partial fractions. Yeah. This is a great question now. Integration, trigonometry, trigonometric identities, substitution, partial fractions. Great. Okay. Can you do the partial fractions? Well, you know it's going to be, what, 1 plus u and 1 minus u? Yeah? Let's just put brackets in there. And du. Maybe you can do it in your head without partial fractions. Okay? Here you are. I'm going to suggest this. 1 and 1. Okay? So you'd have 1 minus u there, 1 plus u there when you put them together. and of course the u and the negative u cancel. Okay, if I add them together like that, okay, I'm going to get 1 plus 1, which is 2. That's too much, I need a half. If that was a little bit too quick for you, sorry, go and do the partial fractions, but you'll get that. Okay, and it's slightly easier, by the way, if you put the half there rather than half over this and half over that. Okay, you get that? Good. I'm glad you said yes. Right, now's the time to take the screenshot. Okay, there we go. And then I'm gonna just rub the board and just yeah, do some more working. Yeah, this is normally a large board worth of work. This and it is a cracking question. It really is nice. Okay, so I'm going to leave that there because it reminds us what the actual question was. Okay, so we'll do this. Okay, and what's that going to give us? That's going to be half of, and these are natural logs, aren't they? Natural log. Let's forget. I've got to put modulus brackets in. 1 plus u plus 1/2 natural log 1 minus u. Whoa! Let's change that plus straight away, shall we? We want that. Because when we differentiate this, you get negative 1. This will be negative 1/2 natural log 1 minus u plus c. Okay. We can simplify it a bit more, can't we? So 1/2 natural log, see what I'm doing here? 1 plus u over 1 minus u. Which is looking like quite a nice answer, isn't it? Let's just rub this off. Okay. What did I say u was again? Sin x. Oh, glad I remembered. So 1/2 natural log 1 plus sin x over 1 minus sin x plus c. So you could say that's your answer. Well, actually, I am saying that's your answer. Okay, but I did say, didn't I, that the answer was this: natural log sec x plus tan x. When I say that's our answer, because that's the preferred form. Okay, you see, it's neater than that, isn't it? Much neater than that. So things, how do we change this into this? How do we get rid of the half? Where's that going to go? Okay. Right. Remember rationalizing the denominator? Okay. Or realifying the denominator, complex numbers. Yeah. We're going to try and have a go at that. Okay. So what I'm going to do is I'm going to times top and bottom of this fraction by 1 plus sin x. And you might think, how does he know to do that? Like I say, it's like, when you've seen this sort of question before several times, you get a knack for these things. Okay. It's like when you're out for a country road drive, okay, whether it's in Luxembourg, UK, wherever, okay, and you know you're going for a drive and you know the road almost like the back of your hand, and you think, oh, I'm going to go down this route because it's nice. I'll go down this route, okay. And as a passenger who's in the car, like, where are they going? How do they know to do this? How do they know to turn down there? How do they know going this way is much quicker? Because they've got experience of those roads. I've done it so many times before. Okay, same with this really. With integration, you know, once you've got that, you know, when I was at university, I was slightly irritated, but also impressed at the same time when I asked my lecturer a question. Okay, I cannot remember what the question was or what it was about, but I remember what the answer was. It stuck with me since then. It was a tutorial, and we were doing something really difficult for me. Okay, and it was like, you know, and I said, well, what do you do? And he said, I know, let's try this. And you know what? His method worked. And I said, okay, can we just go back to this bit? When he said, okay, let's try this, I said, how did you know to try that? And he went, experience. Kind of annoyed me at the time because it meant, damn, I'm going to have to wait a long time to get that sort of experience, okay? Because he was many years older than me. Yeah, I'm saying the same thing here, really. It's like once you've done this enough times, that's part of the video, okay? It's part of me showing you how to do it, okay? So yeah, I know to multiply top and bottom by 1 plus sin x because I kind of know what's coming, okay? And with this integration, you've got to try and predict what's happening. You've got to be 1 or 2 steps ahead, okay? You've got to know. You've got to think, right, if I try this, this is going to happen. No, that's not going to work. So I'll try this. This will happen. No, it's not going to work. I'll try this. Oh yeah, it's got potential. See what I mean? So look, So I'm going to multiply the top by 1 plus sine x. What do I get? 1 plus sine x times 1 plus sine x plus sine x squared. Times the bottom by 1 plus sine x. Right, let's write it down like this first of all. 1 plus sine x, 1 minus sine x. Okay. Difference of two squares, isn't it? So 1/2 natural log, and on top 1 plus sine x squared. Do not want to do anything with that. 1 minus sine squared x. Okay. You might be thinking, that's very well and good, but how do we get to this? Yeah, it's like you never quite see it until the very end, really. Okay, let's just rub off a bit more. Maybe you'll just pause the video and try and do it, or you'll think about it while I'm doing this. Yes, it's always a shame when you have to rub off such lovely maths. It's like, you know, sometimes after a calculus lesson, sometimes I don't want the next class to come in, you know, because I've got to get rid of this board. And I'm like, oh, I don't want to get rid of this. It's so beautiful. It's like, imagine you're an artist, yeah, and you're drawing this lovely picture on the board. Okay, it's like, oh, this is my best work of today. Look at that. Yeah, end of the lesson. Right, you're going to rub it off for the next class. It's kind of how I feel about the maths that goes up on my board. It's like, yeah. But I mean, you know, all jokes aside, I know this could take me just a minute to do again. Okay, whereas with the lovely artist thing, it probably takes hours. So yeah, I'm being a bit unfair, really, aren't I? Okay. So it's not quite the same, really, because I can do this again in another minute. But, you know, it's like, still, I'm like, oh, I don't want to get rid of it. Anyway, let's keep them going, okay? Because maths is art. Maths is my art. Maths is, yeah, art's to me. And art is like what you make of it, isn't it? It's like what you think of it, okay? It's just like, yeah. Enough said, I think. Stop butchering them. So, there we go. Half natural log of, no, I'm going to keep the 1 plus sine squared x, 1 plus sine x rather, all squared. And how else could we write 1 minus sine squared x? Indeed, we can write it as cos squared x. Can you see where this is going now? Remember that question I asked earlier? How are we going to get rid of the half? Use the power rule. Okay, use the power rule. Okay. Do you need me to write that down? Do you need me to write a square root of this? Or are you happy if I just square root this? Okay. I think you'd be happy if I just square root this, wouldn't you? So 1 plus sine x on the top and cos x on the bottom. And it's probably only now where you begin to see how we're going to get this answer. Okay. I hope you've seen it. Okay. 1 over cos x, of course, sec x. Sin x over cos x, of course, tan x. And then plus c. And that is an absolutely lovely, lovely question. Okay. It's got to be right up there as one of my favourites. I don't quite have a top 10, or even a top 20, or top anything for that matter, but that's somewhere. Okay, it's just really, really nice. Okay, lots of good stuff. Okay. Hope you enjoyed that almost as much as me, because you probably can't enjoy it as much as me. Okay. Why can't you enjoy it as much as me? Because when you're actually doing it, okay, and you've been doing it for a long time, then you'll probably really enjoy it. Okay. Because trust me, if you can still enjoy this just as much or even more than when you first saw it, yeah, you know you'll love maths.